In this video, we are going to discuss Lopita rule. Okay, what is Lopita rule? Okay, suppose that we have one of the following cases. Number one, if we have limit x to a, fx over gx equals to 0 over 0. And number two, if we have limit x to a, fx over gx equals to plus minus infinity over plus minus infinity, where a can be any real numbers, infinity or negative infinity. In this case, we have limit x to a, fx over gx equals to limit x to a, f prime x over g prime x. Okay, this means, okay, if we want to solve limit, okay, and if we use direct substitution, the answer gives 0 over 0. Or if we use direct substitution and the answer gives plus minus infinity over plus minus infinity, what we have to do is we need to differentiate numerator and differentiate denominator. So that is Lopita rule. Okay, Lopita rule say that if when we evaluate limit, the answer gives 0 over 0 or plus minus infinity over infinity when we use direct substitution. So what we have to do is we need to differentiate numerator and differentiate denominator, but never use quotient rule. Okay, because this is not under differentiation topic. Okay, but actually this is under limits topic. Okay. In Lopita rules, as long as the previous application of Lopita rules produce an indeterminate form, so it is okay to repeat it as many times as necessary to reduce the limit to a form that can be evaluated. Although Lopita rules involve a quotient fx over gx as well as derivatives, the quotient rule of differentiation is not involved. The expression in Lopita rule is limit x to a fx over gx equals to limit x to a f prime x over g prime x. Means that we differentiate numerator and we differentiate denominator, not limit x to a fx over gx bracket prime. Okay, this means we differentiate using quotient rule. Okay. Okay, for example, if we have limit x to 2, x squared minus 4 over x minus 2. If we use direct substitution, the answer will give 0 over 0, which is an indeterminate form. So, what should we do? We need to use Lopita rule to find the limits. Okay, and when we use Lopita rule, we need to differentiate numerator and denominator one by one. Okay, so after that we can simplify and then we can substitute x equals to 2 into variable x, and the final answer is 4. Okay. Okay, let's say if we have the same question and when we use Lopita rule, let's say we use quotient rule because this is division function. Okay. Okay, under quotient rule, the formula is vu prime minus uv prime over v squared. Okay, so after we substitute into quotient rule formula, we get this. And after we simplify, okay, we have numerator exactly equals to the function in denominator. So we have limit x to 2 is 1. Okay, and then under properties of limit, we have constant 1 here. Okay, so the answer when we use quotient rule to differentiate will given equals to 1. Okay, but the first one is the correct method and the second one is the wrong method. Okay, the first one is the correct method because we use Lopita rule, we differentiate numerator and denominator one by 1. Okay, the second method is wrong because we use Lopita rule but we differentiate using quotient rule. Okay, so this is wrong method, but this is common mistake. Okay, so you need to be careful. Okay, never use quotient rule to differentiate division function under Lopita rule. Okay, but we need to differentiate one by one. Differentiate numerator and then differentiate denominator, because this is not under differentiation rule. Okay, but this is under Lopita rule topic. Okay, to evaluate limit. Okay, Lopita rule should not be used if the limit is not in an indeterminate form. It is because in a determinate form, we only use direct substitution to evaluate limits. Okay, for example, if we have limit x to 0, x squared minus 4 over x minus 2, okay, after we use direct substitution, okay, we substitute 0 into variable x, we have 2. So this is determinate form, not indeterminate form. So it means that we no need to use Lopita rule, but we just use direct substitution. Okay. Okay. Let's say if we have the same example, but we use Lopita rule. Okay. Under Lopita rule, we need to differentiate numerator and denominator. So we get this. After we differentiate denominator, we get 2x, and after we differentiate denominator, we get 1. Okay, and then after we simplify, we have limit x to 0 to x, and then we substitute x equals to 0 into variable x here. So we have the final answer equals to 0. Okay, so when we compare, it gives the different answer. Okay, so from the different answer, okay, which one is the correct method? Okay, actually the first one is the correct method, because if after we use direct substitution, the answer give determinate form, okay, means not 0 over 0, so means that we need to use direct substitution, not use Lopita rule. Okay, so if we use Lopita rule, okay, when we evaluate limits under determinate form, so it is wrong method. Okay, this is wrong. Okay, so you need to be careful. Okay, so the conclusion is the first one, okay, we can do. The second one we cannot do, means that we never use quotient rule to evaluate limit under Lopita rule. Okay, and the third one also we cannot do, means that if we have in terms of determinate form, okay, we just use direct substitution, not use Lopita rule. Okay, got it? There are 5 types of indeterminate form when we evaluate limits using Lopita's rule. The following examples are from each of the 5 types of indeterminate form. Okay, let me look at examples involving the use of the Lopita's rule to evaluate limits for indeterminate form. Okay, the first one is under type 1, which is 0 over 0. The second one is under type 2, which is infinity over infinity. Type 3 is 0 times plus minus infinity. Type 4 is infinity minus infinity. And type 5 is 1 the power of infinity, or 0 the power of 0, or infinity the power of 0. Okay, let me look at example for type 1, okay, which is indeterminate form 0 over 0. Okay, for this example, if we have limit x to 1, x squared minus 1 over ln x. If we substitute 1 into variable x, okay, we have 0 over 0. Okay. And b, if we substitute 0 into variable x here, okay, we also have 0 over 0. So this is under type 1. Okay. So we can use Lopita rule. Okay. If the final answer gives 0 over 0 after we use direct substitution. Okay. Okay. And then for example under type 2, okay, find limit x to infinity ln x bracket squared over e the power of 2x. Okay, if we substitute infinity into variable x, so we have infinity over infinity, which is under type 2. So we can use Lopita rule. Okay. Okay, and then under type 3, okay, limit x to 0 x ln x. If we substitute 0 into variable x, so we have 0 times ln 0. Ln 0 is infinity. So we have 0 times infinity. So this is under type 3. Okay. And then if we have limit x to 0, 1 over e the power of x minus 1 minus 1 over x. If we use direct substitution, we have 1 over e the power of 0 is 1. So we have 0 in denominator. Okay. So we have 1 over 0 minus 1 over 0. Okay. 1 over 0 is infinity. Okay. So this is infinity minus infinity. So this is under type 4. Okay. Okay. And then look at example limit x to 0, 1 minus x the power of 1 over x. If we use direct substitution, we substitute 0 into variable x here. So we have 1 the power of 1 over 0 means 1 the power of infinity. Okay. This is under type 5. Okay. And b, limit x to 0 from the right x the power of sine x. Okay. We substitute 0 into variable x here, so we have 0, and then sine 0 is 0. So we have 0 the power of 0 after we use direct substitution. So this is under type 5. And then C, limit x to infinity ln x the power of 1 over x. If we substitute infinity into variable x here, so we have ln infinity, which is infinity. And then 1 over infinity is 0. Okay, so we have infinity the power of 0. Okay, all of these are under type 5. Okay, so from type 1, type 2, type 3, type 4, and type 5, we can use Lopita rule to evaluate the limits. Okay, but okay, let me go through one by one. Okay. Under type 1, we can straightforward continue to apply Lopita rules. Okay, if we have 0 over 0 after we use direct substitution. Okay. And if we have under type 2, which is we have infinity over infinity after we use direct substitution, so we also can direct continue to apply Lopita rules. Okay. Okay, but if we have the example under type 3, which is 0 times plus minus infinity, what we need to do is we need to write in the form of fraction first before we applying the Lopita rule, because this is multiplication operation. Okay, to direct continue to use Lopita rule, we need to write into the fraction infinity over infinity or fraction 0 over 0. So that's why we need to write in the form of fraction first. And after that, we can use Lopita rule to evaluate the limit. Okay. Okay, for example 4, okay, from this example, we need to standardize the denominator and write it down to a single fraction first. Okay, now we have two fractions here, so we need to write into single fraction first before we applying Lopita's rule. Okay, Because from type 1 and type 2, we have single fraction. Okay. Okay. So, in type 5, okay, we have power here. Okay. So, what we need to do is, we need to take natural logarithm or ln and use the properties of logarithm log am the power of p equals to p log 8m. Okay, to write in the form of a multiplication function, okay, then turn into fractions before we applying Lopita's rules. Okay. Okay, so the conclusion is from type 3, type 4, and type 5, we need to change into the fraction first before we get either in type 1 or type 2. Okay, and after we get in the form of type 1 and type 2, then we can use Lopita rule. So make sure if we want to use Lopita rule, first step we need to write down into the form of single fraction first. Okay, got it? Okay, coming up next, Lopita rules. Yeah. Thank you for watching. Stay tuned. Bye. Assalamualaikum.